Alright, on the back, so it says Hugo and Rose love to collect triangles. Hugo has a collection of 98 30, 60, 90 triangles. So he's got 98 of those types of triangles. Which he's very proud. Thank you very much. Rose is partial to isosceles triangles. Isosceles right triangles. And she has 102 of those. So we're going to find out these two questions about these two people. So part A says Hugo's going to reach into his bag. He pulls out a 30, 60, 90 triangle. Well, that's good. So this is what he picked out first. Oh, he pulls out two triangles. Okay, so he pulls out a second one, because in his bag this is all he has. So he has to take these ones out of his bag. What is the probability that they're similar? Well, that would be 100%, because that's all he has in a bag. So he only has 30, 60, 90 triangles, which are all similar by angle-angle similarity, because they all have the same angles. So that's a 100%. So the next part B says Hugo's going to pull one from his bag, so we know he's got the 30, 60, 90s in his bag. And Rose pulls one out from her bag. Well, we know that she has a right triangle that's isosceles, so that has to be 45 degrees. What's the probability that these two triangles are similar? Well, that would be 0%, because the angles are different. Remember, for similar figures, you need to have all the angles to be the same. So those were those two. These ones are kind of like the spinner ones that we did in practice, where we saw that one of the spinners was just 100%, so you had to keep getting that same number. Kind of the same deal here. It's all the same triangles, so you have to get the same triangle every time. Here you have to get a different triangle every time, because those are the only triangles that exist in the bag. Alright, so then we get down to this section where we had to prove if these things were congruent or not congruent. If you needed to add extra things other than givens, then you needed to state whatever you used to prove that they were congruent. So this first one here, we've got triangle PQR. We got to figure out what it's congruent to. So if we go from P to Q, that's going to be that blank side. Q to R, that's going to be over here, and then we're going to have to go back R to P. So let's see if we can figure this out. Well, P to Q. Now we have to say, alright, so I'm going to go across the blank side. So that's going to be V to S. So V to S. Alright, then what we got to do is we got to say, alright, we're going to go across the long side. S to U. Okay, that looks good. Alright, and then the last thing we're going to do is go U to V. Well, I got a little bit confused because it looks like my printer didn't print out the angles that we have on there. So that would probably be a good idea to put in the double angle that we have over here that's on your paper. So there's a double angle right there, a double angle on the V. Then we have a single one on the R, and a single one on the U. Alright, that got kind of confusing. I need some angles. So we go from one angle, one tick mark, two angles, one angle, one tick mark, two angles. So that's definitely ASA congruency. So that's one of our congruencies that we have. So we put them in the right order. We've kind of matched them up, so they look pretty good. Alright, so the next thing that we have is we've got these two triangles, HJK. So we're going to go from the blank side to the one side to the two side. So over here, we'd have to go the blank side to the one side. That's LK. Then back to the two sides. That's MLK. Alright. Well, we've got two sides. That's not enough to prove anything. But we do know that these two angles are vertical angles. So we would say that vertical angles are congruent, or equal in measure. As long as you put down something about vertical angles, that's what the whole goal was. We needed to figure out that these two angles were vertical. So then we have a side angle side, so that's what our thing is. We have side angle side congruency. So our next set of triangles, we have BOX, and this triangle over here, well, there's no marking on any of the sides, so we can't really prove any of the sides to be similar. Well, we've got two angles though. So that's a good thing. We can use the property that if we have two angles, the third angle's also got to be the same. So we can do triangles add up to 180. So that we can just basically say that those are the same. So we do know all of the angles, but we know no information about the sides. If we look at our sheet of our 5 different triangle congruencies, all of them involve at least one side. So unfortunately, these ones are not similar. Oh, sorry, not congruent. They are similar by AA, but they're just not congruent because angle is not congruent. We can't actually say that that's one of those. So we don't have anything for that one. The last triangle, it's pretty important that you see this right angle here. So we can call that a right angle also, because we can say, along the line is 180. So we have that. So we have two right angles, and we have two sides that we know that are the same. So this one is hypotenuse leg, because we have the hypotenuse, and we're going to get a leg also. Since with these we have a shared side. So that would be the other thing. We'd say that IT is equal to IT, because we have a shared side. So we have our hypotenuse and our leg that are the same. So if we go MIT, so that's going to be the blank side. The blank side is NI. Then we have to go to the two sides. So that'll bring us to T. And then the third one will be the 1. And so that'll set us up. So we definitely have hypotenuse leg. Now this one you could have done this, and then you can do a little bit of Pythagorean theorem or some trig to get all the other angles and all the sides. So if you did do that, you wouldn't have to use hypotenuse leg as your property. You could have used whatever you got. So any one of the congruencies all work kind of with each other. Hypotenuse leg is a special case because we do have this 90-degree angle right here. Alright, last one we had is number 8, solve for theta. So we have 3 sides. So if you remember back from last chapter, if we have all the sides, we've got to use the law of cosines. Alright, that's not too bad. So what we're going to do is write the law of cosines. That's c squared equals a squared plus b squared minus 2ab cosine theta. Alright, theta, we also call that like big C. So these two are the same. So c is always across from theta, so that's got to be 15. So I've got 15 squared. A and b don't really matter. I'm just going to call a 12 first. 12 squared plus 17 squared minus 2, 12, 17 cosine theta. Alright, so it looks like we got a little bit of math to do, a little bit of algebra, a little bit of simplifying. Except we kind of did that already in number 1. We have the exact same problem as number 1. So at the end we're going to get 0.51. So we have 0.51 equals cosine of theta. So at this point we have to take the inverse cosine. So we'll do cosine minus 1 of 0.51 equals theta. And this is something that you're going to want to put into a calculator, unless you know the cosine of a half. But even then you'd only get kind of close, you wouldn't get the exact number. So we're going to go ahead and do cosine of 0.51, cosine minus 1. Alright, and when we do that we get 59.33. Just for our rounding, so you could get anything from anywhere around 59 to about 60, because cosine of a half is 60 degrees. So somewhere around there will give you your value for theta.